Welcome to this overview of stationary fuel cells for backup and off-grid power generation. Stationary fuel cells are advanced devices that generate electricity, primarily from hydrogen. These systems are highly relevant, providing reliable backup power for critical infrastructure and offering off-grid solutions in remote areas. As an efficient, cleaner alternative to traditional systems, fuel cells meet the growing need for sustainable backup power in response to rising energy demands.
How a stationary fuel cell works. At the anode, a catalyst ionizes the fuel, turning it into a positively charged ion and a negatively charged electron. The ions travel through the electrolyte to the cathode. Unstirred, the ions are reunited with the electrons and the two react with the third chemical to create emissions. The free electrons travel through a wire creating electric current. In addition to electricity, fuel cells emit water vapor and heat, like the fuel cell electric vehicles that emit only water vapor and warm air. But depending on the fuel source and electrolyte that they use, very small amounts of other emissions can be produced, like CO2. Most fuel cells are powered by hydrogen and therefore consider zero emissions. However, some types of fuel cell systems are capable of using hydrocarbon fuels like natural gas and biogas.
Now that we comprehend how fuel cell systems work, let's explore one of its current main uses, as a backup power source. This is an alternative energy source that activates when the main electrical grid fails, ensuring continuous and reliable electricity for critical systems and operations, such as data centers, telecom networks, and hospitals. Almost always, there are electricity supplied by the grid. However, in the unfortunate case of, let's say, a tree falling on the electric cables, the electricity may be interrupted. Here's when a backup fuel cell system comes in, substituting the grid. This source of energy needs some initial power to start up, which could be provided by a battery. Within just 1 minute, this alternative system could be functioning at its full power. This current, however, will be DC, causing the need for a converter to alternating current. And there's another detail. Their voltage production oscillates. This calls for the need for a DC to DC converter, which will ensure the constant voltage supply that's needed.
Off-grid power generation systems operate independently from the main power grid, making them essential for areas where grid access is unavailable or unreliable, such as remote or rural locations. Fuel cells are a highly efficient solution for these systems, offering significant advantages over traditional generators. They generate electricity with minimal environmental impact, operating more quietly with greater efficiency, and producing far fewer emissions. One common application is in telecommunication towers located in remote regions. For example, a fuel cell in Romania, powered by ammonia, can keep a tower operational for an entire year with just a single tank. In extreme environments like Antarctica, research stations run emission-free with fuel cells using methanol, providing over 100 days of power without requiring maintenance. Rural microgrids, though not yet widespread due to costs, are another potential application, delivering much-needed electricity to developing regions. Fuel cells are also making their way into urban microgrids, seamlessly integrating with renewable energy systems like hydrogen to create cleaner, more sustainable energy solutions. On an industrial scale, companies like Honda and Bloom Energy offer modular fuel cell solutions capable of generating several megawatts, proving that fuel cells can serve as a primary energy source for large operations.
While fuel cells may have a higher initial cost compared to traditional systems, their long-term advantages are substantial. They offer lower operational costs and significant emissions reductions. The stationary fuel cell global market is projected to reach $8.7 billion by 2028, driven by the increasing demand for clean and resilient energy solutions. In conclusion, stationary fuel cells represent a clean, efficient, and scalable option for both backup and off-grid power generation.